multiply binomials with radicals, and we are going to simplify them. We're going to have a binomial times a binomial or a monomial times a binomial. And what that means is a multiplied chunk of one thing times a chunk of two things, or a chunk of two things times another chunk of two things. So that's what we mean by mono and bi, or bi times bi. So let's work through this first one. If we look at our chunks that we have, our multiplied chunks, we have a chunk on the outside, we have two chunks on the inside. And what's going to happen is whenever you have those different chunks being multiplied by each other, you need to distribute. So we're going to distribute that to each chunk. Always take the time to draw out these boxes unless you see that very clearly, because otherwise what people tend to do is multiply that root 10 by the 5 and multiply it by the x, and that would be wrong. So don't do that. Put the box around it and just know that you only do that multiplication once. So the first thing we have here, we have 5x times root 10, so 5x root 10. Just write it like that. Second one, we have 2 root 2 times root 10. 2 root 2 times root 10. So you tend to write when you're writing these out, you should always write your whole numbers first and then your radical part second. That's just kind of the standard convention with those. So if I look at what I have, 5x root 10 looks pretty reduced. 2 root 2 root 10, well 2 times 10 is 20, so I could write this as 2 square root of 20. I could have gone directly into breaking it down, or I could do it from here. It's kind of your choice. I'm going to break this down because I know that 20 reduces. 4 and 5. 4 breaks down to 2 and 2. I see a pair of 2's and a leftover 5 under my radical, meaning I'm going to have 2 times 2 out front, square root of 5 left over. And 2 times 2 is 4, so I'm going to have 4 root 5 here. So if I go back to my original problem, I have 5x square root of 10 plus what I finally got down here, 4 square root of 5. Now if you're wondering, hey, you skipped a step, your 10 breaks down to 2 and 5. You're right, it does. But are there any pairs in there? There are not. So it's always good to check for that, but if you end up not having any pairs, a number like 10 or a number like 6, where you're never going to get perfect squares inside of them, you will not be able to break those numbers down. They'll be left as square root of 10. So this is actually your finalized answer. There's nothing in common with these two roots, so you can't add your like terms. Try one other one here before moving on to some of the binomials. Again, I always like to start with my squares. So I have a thing on the outside, one term on the inside, a second term on the inside. And when you're doing this, it may be helpful to use different colors for the inside and outside so you know where you need to make your connections. So every inside gets connected to every outside, and it would look like this. Square root of 5 times square root of 10x. Root 5 times root 10x. Plus root 5 times 2x cubed. So whole number 2x cubed, square root of 5 out front. And when I do it that way, I see that I can combine 5 times 10 to get 50x all under a single square root. Or, like I had mentioned in a previous video, we could just write it as one root, 5 times 10 times x. Gets us closer to breaking it down. 10 is 2 times 5. But this time, I have a 5 and a 5 that are paired up, all under the same radical, even though they're written that way, under the same radical. A leftover 2, a leftover x. So this one becomes 5 out front. Nothing was out front originally, so just 5 out front, square root of leftover 2, leftover x. On the other side, 2x cubed root 5. 5 does not break down. The 2x cubed stays out front then. So I just kind of bring that straight down. I don't really change anything about that. I just write it. Those radicals are different, so I am done. Let's do a quick example where things are not going to be quite so clear at the end. And actually that might be easier to do with the binomials. So let's skip to this example right here. In our first binomial we have a pair of things. We have a 6 and we have a second chunk, negative 6 root 2. And I'm going to actually put a square around the negative because otherwise we tend to lose that negative sign. Do the same thing over here. I have the 4 and that negative belongs to the 6 root 2, so I'm going to put a box around the whole thing. And like before, everything gets connected to everything in opposite parts. So this 6 goes to both of these. This negative 6 root 2 goes to both of these. So every box in one part being multiplied gets multiplied by every box in the other part. That way all your terms end up multiplying. So let's write this out. First one we have 6 times 4. So we're going to check that one off. 6 times 4 is 24. Next one we have 6 times negative 6 square root of 2. Kind of a handful. 6 times, I'm just going to write it out, 6 times 6 square root 2. We'll deal with the actual math later. And then over here we have negative 6 root 2 times 4. So now we're going to that one. Minus 6 root 2 times 4. I'm not even going to keep it in my nice order. And then the last one, negative 6 root 2 times another negative 6 root 2. So negative 6 root 2 times negative 6 root 2. So this one's a little tricky. Don't lose me. There's a negative there. And I might even put parentheses around this to remind me that this is all being multiplied. So here I already did the 4 times 6 is 24. So I'll just write that again. 6 times 6 is 36, and the negative sign comes along. So negative 36 square root of 2. So that's done, that's done. Then I've got the negative 6 times 4 out front, which is negative 24, but it's also got a square root of 2. And then finally I have this convoluted mess down at the end here. Negative 6 times negative 6, so minus a 6 times a negative 6, positive 36, or minus a negative, so either way, positive 36. Square root of 2 times square root of 2, you could think of that as, oh, it's square root of 2 squared, just 2. Or 2 times 2 is 4, square root of 4, which is 2. Either way, you get 2. And if we were to go one more step with this, 36 times 2, pop that in your calculator, you get 72. So now we have a whole number, something with a radical, another thing with a radical, which happens to be the same radical, by the way. That's convenient because they can be combined, and then a whole number. So let's combine our whole numbers. 24 positive and 72 also positive here. So 24 plus 72 would be 96. And then over here, these are both root 2's, so you can add these numbers as well. You have a negative 36 and a negative 24, which add up to negative 60 square root of 2. The root 2 comes along just like as if it were an x. So sometimes after doing all this multiplying, you have to look and say, oh, things can break down. I can go ahead and simplify this further. And when that happens, you get something like that. So all these examples will work through different things like that. What you'll find is that whenever you have a radical times a radical, especially when they look the same, like you would in the last step of this next example, you're going to see that coming out as just a whole 3r outside the root. And those numbers can sometimes get pretty big, so keep a calculator handy to be able to work through these one step at a time very methodically.